Well, g'day, Max here again. Welcome back to the shop. So today we have quite a straightforward little job. It's just a bit of a sleeve repair in this hub here. A little bit flogged out in the middle. So we'll show you what what our plan is. So the outer wheel bearing on this hub, this is an obsolete hub. You cannot get them anymore, and the cost. Well, to replace this, you've got to go with a modern version. That means replacing the hubs on both sides of the axle, and then cutting off the brake backing plate and repositioning that in the correct position for the new style hubs. And so what the plan is with this is just to, where the bearing goes in, this isn't, well, it used to be the bearing. It's out of a different one. This is one that's, I've ground away the outside, and this is one that I use when I do these. So the bearing is tight at the start, but when it's in its position, it's loose. So this one here is just a knocker in tool that I use. So I knock the bearing in till it's flush, then I can invert that over the top and continue drifting the bearing in till it seats in place. But yeah, when the bearing is down there, it's loose, the proper one. So we're gonna sleeve the bore here. So one thing we've got to be very careful of is we don't want to take away the strength of this. It's cast iron, so we're not going to, when we bore this, we're only going to take it to the edge of that chamfer, and that's it. And that will give us probably about just under 2 millimeters, or about a 2 millimeter wall thickness, 80 thou wall thickness sleeve. So we'll machine, we'll bore it out, machine up the sleeve, press it in, and then take a final skim cut through the bore to suit the bearing. The reason why I'm not going to finish the sleeve is, which we can go that way, and I do go that way with some things. So that means a finished sleeve, when we press it in, that's it, the job's done. There's no need to bore it out. It comes out, if you do your measurements correct, it comes out at the right size press fit. So you've got to bore it oversized to allow for the crush, which is not a problem to do. But in this case, because it is such a thin sleeve, we do want a good round bore. So that's why I'm going to bore it after I've pressed the sleeve in. So what we're going to do is we turn our hub over. What I'm thinking of doing is gripping it on here. So what we can do, this is has the draft in it from the casting. It's a bit, you can see it's thicker one side than the other. So what we could possibly do, this is a machined area, this nose is machined. And I've still got the soft jaws set up for approximately that diameter from our last job in the small lathe. So I can grip that on here. Then I can come in with a tool and just turn a short parallel section down here. Then we can turn this over, grip it by our freshly machined area. That will ensure everything's running true to the bore. And then bore our hub. So I think that's going to be the best way, because all these would have all been machined in the same setting, and we don't want to go, we don't want to lose our concentricity with the inner bore, which it's a bit difficult to dial that in as we're sitting that way. So to double check when we are gripping it on here, we can then indicate off either this surface, and then we'll run indicator across the flat, and we'll just tap it all out till it all averages out, and that will ensure we are in the relative correct position for concentricity, and all running true to the rear bore. That's the plan. So looking at where we've got a grip, there's some pretty butchered up areas on this face, and that's from people I probably putting wheel bearings in the past and having no clue whatsoever what they're doing. All the hammer strikes on the outside's incredible. Still, some mothers do have them. So we've got to miss all of that because we're going to be pushing up against this face. So I've marked where I can grip it with a texter. I think we're going to be all right. Now let me go and get an indicator and we'll indicate our bore here. Hopefully we're not going to chase our tail too much with this. So I'm starting to fight this, so I'm just going to go across 4 points. Fuck me. this isn't wanting to play the game, so I'm going to put our bell center in it. Take a bit of weight, slacken off the jaws. We're on a lump. So I'm just moving to another position in between the studs. And I'm holding the chuck and just rotating the drum, and I can feel it's a lot smoother in that position. Give her a bit of a nip down. Okay, we'll get our indicator in there now, see if it starts to behave itself. That's looking better, but we're still nowhere near. Just going to lift these jaws down again. Okay, we're running at 3.5 thou there. We need to improve that. We're running at 1 thou. Shit, too far. Whoa. This is why I don't quote these jobs a lot with a very, with a light price. I tend to quote them a bit heavy. This is why. Yeah, we're on 2 thou. One thou there. Just so I could see one side to the other, what was happening. So we're going to roll with it. They're both 1/2 thou indicators. So that's, I'm not going to pursue this any further. We'll put a bar in now, and then we can get a cut on this hub here. It's only got to come in probably 1/2 inch, 12, 13 millimeters, just so we can establish a true surface. It doesn't have to be all the way around, just as long as we've got a true surface and 3 spots where we can grip on with the lathe chuck. We'll just make sure too, I just run around with the jaws again, make sure it's tight. just tight enough so it doesn't move when we machine it. Lovely. Okay, I just went to, I've just set my tool up and brought the tool in closer, and I've seen a bit of movement in that bore. So we've got 15th hour run out there again. And 20 seconds prior to that, I had my indicator in there for a last double check, and we were pretty bloody close. This thing's moving by itself. Now, I can grab this. It's not moving. I can tap this back true. We'll come back in a couple of minutes. We'll see what's going on. Like, that's moved 20 thou. Okay, with 2 thou. No wonder I'm chasing my tail. Okay, that's running at 2.5 thou. We'll come back in 5 minutes. So I'll leave the indicator on 0. Okay, that's been about 2 minutes. Check this out. 9 thou. So it's just moving, it's just squirming. Okay, so we've got to come to a different plan. Right, end result. We've clocked our bore up within 1/2 thou. We've taken out the wheel studs. There's about a 10 thou run out on the wheel face. So we're going to leave it at that. We're going to bore through for our sleeve. We'll fit our sleeve, machine our sleeve. And then what we'll do is we'll just take a skim cut on this face here to take some of that out of it. That's all we're going to be able to do with this thing. Right, let's get it bored out. So yeah, as you'd expect, there's a bit of warpage in the thing, so all good. Yeah, so plan B left us no option but to take the soft jaws out and put our standard inside jaws in and grip the other side bore by the bearing diameter with the inside jaws. It was the only way we could get it. Okay, we'll get a telescopic gauge and start keeping track of our measurements. Actually, we'll go a bit smaller than 1940, I think. We'll bore it to 1910, I think. We'll see how we're going from there. The 48th hour to go, so okay, I'm just going to take a spring pass through, then we'll get our final measurement. If you look at the outside, you can see the damage that it's copped. It looks like it's not running true. It's running true down here, but the OD just here is a bit all over the shop. The insert's got a fair bit of wear on it, but I generally don't change them till they're knackered. I think we've probably got in the vicinity of 8 to 10 thou to go. Seventh hour will bring us to 1.510. We'll try that. We're a thou under. I think we'll let it go at that. We can make our sleeve to fit. I'm just going to have another double check, and we'll just recheck the wall thickness of our sleeve. So we don't want to compromise this thickness, but we don't want the wall thickness of the sleeve being too thin either, and then that will become problematic when we go to push the bearing in, or next time when they go to remove the bearing. So I'm just doing a bit of a visual, an eyeball sort of a check. And I think we're going to be in a good position there. Let's get a measurement off and deduct our bore off our diameter, and that'll tell us the wall thickness. Okay, we've bored to 1.909, so that will give us a 1/64 thou wall thickness sleeve. So when we make our sleeve, we'll make it to 1.910. That'll give 1 thou interference. That would be the maximum. I might just polish a bit out and just go slightly under that. Being as this is cast iron, we've got to be a bit gentle with it. Okay. Right, let's get started on our sleeve. Okay, so there's not really anything to be gained by machining our bush, say in the other lathe, and then pushing it in here with the tailstock and machining it thinking we're all going to be still all good, because that's actually not the case in this situation, because we've been tapping this around to get it to run true. The rear face it's probably only at most one bit of the rear face contacting the jaw. So as soon as we start pushing on there, we're going to put it out of true. So all I've done is marked a jaw and marked the drum. So when we put it back in, we'll pick up the same corresponding jaw. It should be pretty easy to set up. Okay, let's get our material in that we're going to turn our bush from. So we use this as a donor material for our bush. We've got a few of these. These are actually cab mount bushes off a Caterpillar 657 scraper. I've done a lot of work on those machines, so I always kept bits like this. So I'm only gripping it very lightly. I'm just going to take a minimal skim cut, then flip it round in the chuck, and then we can machine our bush from the other end. Not that much to come off this. About 50 thou. Bit of a hard spot in it. Ah, 1911. We're going for 1910, I think we were. We'll leave that at that. Then we'll do our bore, then we might just polish this off a bit. So bring a tool up there. We need 7/8 of 22 mil of bush. Okay, so we got 10, 15, 20 to run 22. We'll go a bit more for the parting tool. Something like that. I'll just re-zero my carriage dial. Okay, we just got just shy of 80 thou to come out. We'll take another couple of roughing cuts, and then we'll let it cool right off, get a micrometer measurement. Final sizes are, well, our bearings 1781. But we're going to go a bit under that, 757. So we're still about 20 thou. So I'll take another 10 out of it and that'll probably do it. We'll finish the rest off when it's pressed in. So 1.781 is our finished size. Oh shit. 1.765-ish. So we've got a little bit to come out once we're pressed in. And for our interference, will be 1.9095. Yeah. And our OD 1.9105. So we've got a thou interference. So that's good. We can part this off now. 22 millimeters long, 7/8. Yeah, so all our, we didn't end up having to polish anything off the OD. Once it's all cooled to temperature, we were right on our required size. So 22 or 7/8, this will leave a fraction hanging out just to face off once it's pressed in. I'm going to move the parting tool across and I'm just going to take it doesn't matter which end I do it on, but we're already here. I'm just for a couple of mil, I'm just going to plunge in a couple of thou, and this will allow, I'll show you when we've done it. This will act like a pilot or a lead in, and it will help start the bush square. That's all it takes, that little bit there. And when we go to push the bush in, this will ensure that our bush is starting square. So yeah, as usual, I go to press record and either don't press it hard enough and it doesn't record, or that was the case then, or I just forgot to press it. Okay, so we don't need that. We certainly don't need that. Just tidy up this edge here. Okay. That's our sleeve, so we'll go and get it pressed in. Just for a bit of cheap insurance, it doesn't really need it, but I just threw a tiny bit of 620 retaining compound in the bore. And And this press is always a bit of a nightmare to get things started straight. So that's it, she's there. Okay, we're back to the lathe and we'll get the little top there faced off and bored to size. Remember, we marked our jaw and our part so they'll all settle into the same sort of spot. Okay, we'll get this indicated in. It's actually looking pretty good there. It's running 9 thou. Just a tad over 1 thou. It's running about 1/2 thou there. I'll just nip these jaws up a little bit. Remembering that because we're gripping on the bore, we've got to actually unscrew the jaws to nip them. That's running pretty darn good there. We'll let that go there. Just checking the inside of our sleeve, and that's running pretty good too. Okay, so we'll get this faced off to the correct, just so we're flush. And we'll get our boring tool in and get this bored to size. Okay, that looks good. Well, we could pretty it up. We'll just take some of those butcher marks out. Not required, but we'll do it. That's fine. We'll see what we've got to bring out and take out. OD of our bearing is 1781. And a couple of tenths. Going by the book size for this, 1781. As long as we're just under that. We'll probably give it in between half a thousand, well, probably go 1781, that'll be our finished size. This is a couple of tenths up, so that'll be about the correct interference, 2 tenths. Or as close as we can get it to that. Okay, what have we got? 15, bit over 15 thou. I've put a different tool in. I've put a finishing, it's a slightly different bar with a finishing insert. So we'll just take this in a couple of cuts. I'm not sure how it'll go. Let's see how we go on this speed here. Not that one. The speed here. 'Could probably slow that feed down a touch. I think I will. Eight and a half there. $7.80, $7.81. Okay, we're going to run this through. That's 780, this is 781, and we'll just give it a light polish. We're 781 and 2/10, so I think we're right on size for size. $780.5. $781 and 2/10, so that's 7/10,000ths of an inch press fit, which is perfect. Okay, we're good. Okay, I might just take a light skim across this face and see if we can't true it up due to the warp that was in it. Okay, out she comes, and we'll get our studs back in. Blow all the chips out, get our studs knocked in, and we'll get this arm bearing in. Right, job complete. Studs in. Suppose we could finish it off and just tap the bearing in. Should just be a light tap fit. Absolutely spot on. So yeah, as I was saying at the beginning of the video, this is a the camera's shaking. Yeah, it's on the rubber mat that I'm standing on. This is an old bearing that I've ground down the outside, and this allows me to knock these in. It's an easy way to make a special tool. Just use the old bearing. We're home. Home, James. There we have it. Okay, we'll close this one off here. Well, that all went without too much of a drama. Once we got the the thing to cooperate the way we wanted to, well, the way we wanted it to cooperate, and the rest was plain sailing. So yeah, quick sleeve job, no dramas. Anyway, cheers, thanks for watching, and yeah, we'll see you in the next video. Not 100% sure exactly what we're going to be doing yet. We've got a massive list of stuff to get through. I might actually try and slip down this afternoon, because I believe I have to pick up a special piece of equipment for our Bridgeport. So we'll keep that one as a surprise. And yeah, anyway, cheers.